In this video, we're going to talk about algebraic operations, and I just want to share with you that across the board, everything we do in math follows these exact same set of rules. We're not going to teach them separately, we're going to teach them together, and just know that it applies to everything. First off, adding, subtracting. Only things alike can be added or subtracted. That's like 3 feet and 5 feet, 2x and 3x. Things that are alike can be added and subtracted. Multiplication division, we can actually multiply and divide anything as long as we only multiply and divide the corresponding parts. We only combine the parts that are alike. Okay, before I go into this, I'm going to talk about a concept called coefficients. Coefficients. A coefficient is a number that's out in front of a variable, in front of a radical, in front of anything. The coefficient tells you how many of something you have. 3x means I have 3 x's. The number 4 tells me how many i's I have. The number -5 tells me how many root 3's I have. So again, a coefficient tells you how many of something you have. And then you have the like or unlike parts. None of these things that I have listed here can be added. The reason they can't be added is they're not alike. 3x cannot be added to 4i's. They can't be subtracted. 4i's cannot be added or subtracted to -5 root 3, because this tells you the objects that you have. -2y says I have that many y's. 3 times 10 to the 5th, even scientific notation. The 3 is the coefficient. It tells you how many 10 to the 5ths I have. Anytime you have units like 5 feet, 5 tells you how many feet you have. Now let's look at some actual examples to where we're going to look at things that you can add and subtract, things that you can't, and then how you actually multiply and divide. Okay, here's some examples of some things that can very easily be added together. Again, from what I just told you, remember the number out front called the coefficient tells you how many of something you have. And you can only add things that are alike. 3x's can be combined with 5x's. Why? Because they're alike. The number out front tells you how many you have. If you add 3 of something plus 5 of something, you have 8 of that something. Notice the x does not change. Also alike in this problem is a +4 and a -5. Again, the same thing works for addition or subtraction. Make sure that you understand that if something has a negative answer, put a minus. If something has a positive answer, put a plus. So a +4 and a -5 gives you a -1. If you absolutely wanted to, you could have put a plus sign in front of that 8x because it was a positive. Again, a number out front tells you how many of something you have. If you have 4 root 3's and you add 2 more root 3's to that, you get a total of 6 root 3's. Notice that the root does not change. 2 feet plus 4 feet is equal to 6 feet. 3x squared cannot be combined with 4x. They've got to be identical. Again, you have 3x squareds and you only have 4x's. However, 3x squareds can be combined with -5x squareds. That gives you a total of 3 minus 5 is -2 x squareds. 4x has nothing alike there, so we leave it as 4x. This trickles down all the way to fractions that we learned back when we were younger. 2 out of 3 plus 5 out of 3. If they're alike, you can't add them. 2 out of 3 and 5 out of 3 gives you 7 out of 3. Scientific notation, 2 times 10 to the third, 4 times 10 to the third. Again, the 2 and the 4 tells you how many 10 to the third you have. 2 times 10 to the third, 4 times 10 to the third gives you 6 times 10 to the third. Again, you're only adding the coefficients. Now, you might not know what a log is. On this next problem, logarithms, even with our advanced math, we do the exact same thing. You have 4 of something minus, well, there's no number here. I do want to remind you that anytime there's no number, like if I ask you to add 3x plus x, if there's no number, it's understood there's just one of them. So same thing here. We have 4 log x's minus 1 log x's. Guess what? 4 minus 1 gives you 3 log x's. So even though you've never seen it before, those same rules apply. Vectors, possibility you've never seen it before. Now, how do we add vectors? We add the first numbers, the parts that are alike. These have the exact same dimensions. There's 2 numbers plus 2 different numbers. You get a total of a 6 And 2 and 4 also gives you a 6. There's your addition of those two vectors. I can't stress it enough that, again, you can only add and subtract when things are alike. Now, here what I've got some examples, things that are not alike, things that can't be added as they are. However, sometimes we can make things alike, such as 2 feet plus 3 inches. Notice again, 2 tells you how many feet you have. The 3 tells you how many inches you have. Feet and inches are not the same thing. However, sometimes you can change things. Since we know a foot is the same thing as 12 inches, we can change this to 24 inches plus 3 inches, and now they can be added. You get a total of 27 inches. So again, remember that sometimes it's possible to make things alike. Fractions. Notice these bottoms are not alike. We can make them alike. We can multiply top and bottom here by 2, gives me a 4 out of 6. We can multiply top and bottom here by 3, gives me a 3 out of 6. Now, look, the bottoms are the same. They're alike. Things can be added or subtracted when they're alike. 2 times 10 to the third, 4 times 10 to the fourth. Notice, again, the coefficients tells you how many you have of something. But in this case, the something's not alike. Therefore, we could actually change, let's see, if I were to take my decimal and move it one place to the left, that's 0.2 times 10 to the fourth, plus 4 times 10 to the fourth. Notice that I've changed them to where now they're both 10 to the fourth, so now I can add them. The way that you add simply coefficients, 4.2, and you do not change the 10 to the fourth. 2 root 3 plus root 27. You have 2 root 3's and you have 1 root 27. The roots are not alike. You can't just add the numbers out front. However, we can make them alike. If we simplify this radical, the square root of 27 is the square root of 9 times 3. Square root of 9 is 3, so therefore we can rewrite this as 2 root 3 plus 3 root 3. Notice again now they're alike. The root 3's are the same. So you have 2 of something plus 3 of something gives you a total of 5 of that something. Okay, I'm actually saving the easier ones for last year. Multiplication and division, we like to multiply and divide a whole lot more than add and subtract because it's so much easier. To multiply and divide, you can multiply and divide anything, as long as you only multiply and divide the parts that are alike, such as 3 times 2x. Those are not like terms. You would not be able to add those. However, you have a 3 and a 2. Those coefficients are alike. We simply multiply our 3 times 2. That gives me 6. X has no other x's in the problem, so it stays the same. Multiply the pieces that are alike. Next example, 5 times 2 are alike. That gives you 10. X squared and x to the fifth are all x's. We can combine those. We combine those using rules of exponents. X squared times x to the fifth can be multiplied. It gives me x to the seventh. You just pretty much count how many x's you have. Same thing on the next one. 3 feet times 2 square feet. Even though they're not alike, 3 times 2 is 6 feet and square feet. We're going to use the exact same rule of exponents we used up here. We're pretty much counting how many feet we have. Feet times square feet gives me feet to the third power, 6 cubic feet. The next one, 5 times negative 2 are alike. Neither one of them have roots. Both of them are both coefficients. 5 times negative 2 gives you negative 10. And you can multiply a radical times a radical. They're alike. Root 2 times root 3 gives you root 6. Scientific notation, much easier to work with when you're multiplying. 3 times 2, the coefficients out front, gives you a total of 6 when you multiply. To do 10 to the fifth times 10 to the seventh, we're going to use the exact same rules of exponents up here. 10 to the fifth and 10 to the seventh is 10 to the 12. And again, the reason we can combine them is they're both powers of 10. So you can combine powers with x's with other powers of x's, powers of y's with y's, feet with feet cubed, feet squared, 10 to the power times 10 to the power. Fractions, we can multiply any fraction. How do we multiply? We multiply the things that correspond, the things that are alike. The tops, we're going to multiply. The bottoms, we're going to multiply. And we're finished on this problem. Now, we can cross-cancel and all that stuff we learned when we were younger. Now, we got a very complicated looking problem here. 3x squared root 2 feet, 5x to the fifth root 7 feet. To multiply that, simply take the 3 and multiply by what it corresponds with. 3 times 5 is 15. You have 2 x's and 5 x's, which gives you 7 x's. A root 2 and a root 7 gives you a root 14. Don't forget to multiply your feet times your feet. Feet times feet gives you square feet. I do want to caution you about multiplying and dividing when plus signs or minus signs are present. That's when we have what's called the distributive property, such as the first one. 3 is being multiplied by 2x plus 4. Notice the plus sign. There's two things inside there that 3 is actually being multiplied by. So make sure when you have that plus or minus that you distribute the 3. We're going to multiply 3 times 2x. Now that part's simple. That's what we just did. How do you multiply 3 times 2x? You can, because even though they're not alike, you can multiply the 3 times 2 and just leave the x alone. Plus, again, we're multiplying by 3 by both of these. 3 times 2x we just did. 3 times 4 gives you a simple positive 12. You're finished. Distributive property. You can also distribute here 3 root 2. Notice the plus sign. We've got to multiply 3 root 2 times both of these. Can we multiply these? You can multiply anything. 3 root 2 times 4 root 3. Multiply the 3 times the 4. Multiply the root times the root. And you get 12 root 6. We're done with that one. Now multiply 3 root 2 times 5. It's legal. Multiply the 3 times the 5, which gives you 15. The root 2 has nothing to combine with, so we leave it alone. And that's what we get. Now what if we have two sets of plus signs? We do the exact same thing. We're going to take the 5x. We're going to multiply it by both of these. 5x times 2x, to multiply those, you do the 5 times the 2, combine the parts that are alike. The x times the x, we count our x's, and that gives us 10x squared. 5x times 4, we do the 5 times the 4, which gives us a 20. X doesn't combine with anything, so we leave it alone. We're done with 5x. We now do the exact same thing with 3. Again, we're multiplying here. 3 times 2x, and again, notice I'm putting plus and minuses. You can even put a plus out here if you wanted to. If it's positive, put a plus. If it's negative, put a minus. 3 times 2x, we can only multiply the 3 times the 2, and we leave the x alone. 3 times 4, those are alike. It gives us 12. Now notice what we've got going on now. Same thing we had up here. You can only add and subtract when things are alike. These were not alike. These were not alike. That's the reason I didn't add or subtract. However, these two things are alike. 10x squared has nothing to combine with. There's no other x squareds. 20x's, 6x's gives you a total of 26x's. Again, we add and subtract things that are alike. And when you add or subtract, they stay alike. They stay x. And the plus 12 has nothing to combine with. Okay, now let's look at some cases where we're dividing. Reminder, none of these have pluses and minuses. I don't have to worry about distributive property. So to multiply or divide, you simply find the things that are alike, and you multiply or divide them. Coefficients out front, I'm going to go ahead and put my fraction bar. 10 divided by 5 is 2. To divide exponents, x squared and x, you subtract your powers. Now, there's 1 on bottom. And the way I always teach it, subtract your powers, and wherever there's more of them at, that's where you put your answers. The 2's on top, the 1's on bottom, subtract them, you're left with 1. Since there's more on top, I put my answer on top. There's 3 y's and 5 y's. 5 minus 3 gives you 2. Since there's more on bottom, put your answer on bottom, y to the second. I've combined all my numbers, x's and y's, so I'm done. Same thing here. 3 was 6. Now, if I were to divide 3 divided by 6, it's going to give me a decimal. So what I treat this as, division we know is the same thing as a fraction bar. So 3 divided by 6, instead of writing it as a decimal, let's just reduce that. And that's perfectly legal as well. Same way over here, 10 divided by 5 was 2 over 1. So if you'd rather put 2 over 1, it's the exact same answer. 3 over 6 reduces to a 1 and a 2. Divide them both by 3. A root 10 and a root 5. You can either reduce that, you can divide it, however you want to think of it. Root 10 divided by root 5 is root 2. The 1 is no longer necessary, so root 2 over 2, final answer. And again, we can't combine these because one of them's a radical, one of them's not a radical. 10 inches cubed divided by 5 inches, same thing. 10 divided by 5 is 2. With inches cubed and inches, with these units, you're going to use your rules of exponents. 3 inches on top, or the power of 3, inches to the first on bottom, subtract them, and you're left with inches squared. Scientific notation works the exact same way. 2 divided by 4. Now we know that scientific notation we don't leave in fraction form, so I am going to actually divide this here. You could reduce it and get a half, or you can divide it and get 0.5. Also, something different about scientific notation is if I were to subtract this, I get 10 to the 6th power, and it would be on bottom. We're going to leave our scientific notation powers as negative. That's perfectly fine. So you could actually write that 10 to the 6 on bottom as 10 to the negative 6 on top. Now we know that this is not true scientific notation form because our decimal needs to be right here. So that's going to be 5.0. And instead of now moving it left 6 spots, we'd have to move it left 7 spots. So we're going to write that as 10 to the negative 7 power. Okay, one last reminder. Anytime there's a plus or a minus, as there is in this problem, we have distributive property. Now I do want to say about this first problem, notice the tops are alike. 10 and 15 can go ahead and be added, and that's going to be the easiest way to work this. But I just want to use this as an example. Since this is being divided by 5, you have a plus sign. They're both being divided by 5. So you're going to do 10 divided by 5, which is 2. 15 divided by 5, which is a positive 3. Again, you can put a plus sign with both of them if you'd like to. Put a plus if it's positive, minus if it's negative, and 2 plus 3 is 5. And we could have found the exact same answer by just doing 25 divided by 5. However, sometimes you can't combine them, kind of like on this next problem. Now, since this whole thing is being divided by 2x, you have 3 things. 1, 2, 3. They're all being divided by 2x. This, and this, everything divided by 2x. So we're going to do 6x to the third. If you want to distribute it, you can. You can just write it out. 4x to the second divided by 2x. And then you have minus 7x divided by 2x. To divide, again, you divide the parts that are alike. So like your 6 and your 2 gives you a 3. To divide your exponents, you subtract. 3 minus 1 gives you 2 left. Plus, 4 divided by 2 gives you a 2. X squared and x to the first, when you subtract, gives you a single x. Now here you have options. It all depends on if you want to leave your answer as a fraction or a decimal. You could put minus 3.5 because 7 divided by 2 is 3.5. If you don't actually want to divide it, since it is going to give you a decimal, you can just leave it as 7/2. Then the x's, you have x to the first and x to the first, which cancels out completely. That's x to the 0, so you don't have to put them. So again, you could leave it like this, or you could put minus 3.5. Radicals work the exact same way. Here's your plus sign. So we're going to divide this and this both by 2 root 2. Divide 10, and we'll actually write this out. 10 root 6 divided by 2 root 2 plus 5 root 10 divided by 2 root 2. 10 divided by 2 gives you 5. A root divided by a root, you just divide them. Root 6 and root 2 gives you a root 3. 5 divided by 2, again, if you don't want to divide that, since it's going to give you a decimal, you can leave it. Then root 10 divided by root 2 gives you a root 5. And you can put that on top if you would like to. It means the exact same thing. Now the last one. We do not have, notice you have 3 terms on top and 2 terms on bottom. We have special ways of working this. We call them long division or synthetic division. You cannot take each of these and divide by x. You can't take each and divide by 2. It doesn't work. So if you would like to look it up, either synthetic division or long division is going to be the 2 methods we're going to use to actually divide when you have something being divided by 1 or 2 terms on bottom.